Well, hello everyone, I'm Ed, and today I'm going to talk to you about a kind of unsung superpower that I think Rust has, and also a way in which our company has been trying to use this. So for the purposes of this presentation, there are three things that you need to know about me. Firstly, I work at Canonical in the office of the CTO, where among several other duties, I am responsible for kind of promoting Rust amongst our various teams. I'm the guy that goes around and says, hey, you have a problem. Have you tried using Rust? I think it'll be really good. And we're having some success with that. And, well, as I think we'll see that there's some lessons we've learned. I also really like clean code. There's a certain zen to this, and when I find a piece of code that I don't understand, I immediately think, like, okay, right, do I not understand this because it's complicated, or do I not understand this because it's a little bit weird? Weirdness is something I generally like to avoid. This kind of rubs off slightly on others, and I have the effect of really annoying my coworkers over this. I'm that guy who on pull requests will be like, after everyone else has approved, I'll be there saying, oh, there's actually like 20 things we need to go through here. I don't think this is quite ready, sorry. I'm not too popular about that. But anyway, so before starting in earnest, I would like to tell you a little story about a project that we were working on a couple of months ago where we had to bound the amount of CPU time used in a part of one of our processes. For the sake of solving this, we needed to have a solution which was quite lightweight. It had to work in quite an async environment. It needed to be simple. Well, it proved quite a challenge. So the thing that we came up with was the idea that the program would declare a certain amount of work that it had done, and then we would then bound that at runtime to prevent code from running away. So we needed to relate this back to reality, and how we did this was through testing. So we basically we test over multiple input sizes, and we make sure that the amount of time that is declared being used on a particular green thread is above the amount of time that is actually used. Now, wouldn't it be great if this were actually reality? It's not. The data was very noisy. And the property we were looking for is that that white line is always above the orange one, because if we can bound the white one, then the orange one is not going to go too badly. So this data here kind of, there's a lot of stuff going on here. I'm not going to go into too much detail as to why it's so noisy. But what we essentially needed to do was to reduce the amount of noise, because a lot of this stuff, we couldn't replicate it, essentially. Like, it would happen once, and then maybe it wouldn't happen again, but having flaky tests was something we really, really wanted to avoid. So we denoised the data to make it look a little bit more like this. The problem was that to denoise it like this was really complicated. The methods that we needed to implement simply weren't available, so me and my coworker had to go and look at papers and translate some code from GNU Octave and essentially make it so we had a mathematical model that roughly modeled the noise that we were getting so that we can then reduce that. So that took about 2 months of work. It was quite a grueling 2 months, I might add. And the result of this was a bunch of code which was heavily steeped in maths. There were a bunch of kind of magical constants that dropped out of that. But really, when we looked at this, we thought, yeah, between 1 and 2 members of this team currently understands what this code is. And in the future, that number's only going to decrease. So we took this code and we scrapped it. We decided that this would simply not be maintainable, so we went for a much simpler approach. We reevaluated our requirements and found that actually, if we're just trying to stop code from running away, we can take a simpler approach of make sure that the testing pokes the users to have done done approximately some counting, not necessarily like perfect counting like these graphs would give us. So this kind of got me thinking, what could we really learn from this? So I think there's a couple of hard problems that we as an industry face, not necessarily hard coding problems, but hard people problems, really. So firstly, we need to elicit requirements. In our case, the requirements we had, the two of us who were making this code had a slightly different version in our heads of what was required from what really the business needed. So it was some negotiation that was required to take us from the course that we were on to the more relaxed course that actually got us to a solution. Secondly, there's a certain amount of politics involved. If we weren't careful, if we were really, really pushing for what we believed to be right, then although we may have won that argument, it would have been quite unhealthy for the team as a whole. So really, this process was a good lesson for us in learning to lose certain battles strategically in order to win the war. And finally, maintenance. Maintenance is a tough one, because unlike the other two things here, you don't really have anyone to talk to when it comes to maintenance. Best case, you've got some good documentation, or maybe the original person who wrote this, and if you don't, good luck. That's not going to be fun. So, what is maintainable? At its core, I think maintainable is quite difficult to define, but here are some properties that I come up with. Firstly, that if you have very easily described concepts, then I think that's quite maintainable. If you can explain to someone what a little bit of code is doing, then they're going to be, if the code can describe itself rather, then they're going to have a much easier time working on that in future. Now, where you have multiple concepts coming together, you need to make sure that these concepts flow very naturally. If there is an awkward break in this, that's going to cause some real head-scratching later. And finally, we need to make sure that we have very predictable patterns. Now, although this may lead to localized sections of code possibly being slightly worse, overall, the quality of the code base will be improved because it means that the person who's reading this will have to keep fewer patterns in their head as they are going through. So, who are these people who we're trying to write our code for? So, firstly, our coders should be writing for our customers, like, I hope. Secondly, they should be writing for their coworkers, the people who will be building on their work and will be the ones looking at their API and thinking, "Oh, that's a little bit strange. Why did you do it like that?" If you're in close contact with these people, some interesting conversations will happen. But of course, you're not always in close contact, because what if your coworker is someone on the other side of the world who's just like a downstream of you and who's reading your documentation and trying to make best use of your work? And finally, we need to be thinking about ourselves when we are coding, but not ourselves of right now. That's an easy target. We need to be thinking of ourselves in 6 months' time, 12 months, 18 months' time, when all of the current decisions have been forgotten. When you look back at what you wrote and thought, what was I on at that moment? That's really odd. I think we've probably all been there. So, this kind of brings us on to a notion of fearless refactoring. We've identified some problems. How can we start to get around them? And this is a place where I think Rust really shines. So I would define fearless refactoring as the ability that after making a change, the next time that all of your checks pass, code probably still does what you think it does. Now, by virtue of its type system and its fantastic error messages that the compiler can give you, and its lints and all of the great ecosystem around Rust, we're kind of in a uniquely good position here amongst all of the languages seriously used in industry to have our refactors be done, at least it might not be easy, but we can go into them thinking that at the other end, we'll have something that at least works. Which gives us a unique opportunity, because it means that once we have working code, we can easily go back and improve that, which is nice. So there's a couple of things we can do to help the people who are in future going to be working with our stuff. Here are like 5 techniques, like best practices that I've found. There are many more. They'll be mentioned later. Firstly, I'd say you should avoid unwrap. If you can explain something by use of the type system, your code is just going to be far easier to work with and far less error prone. But if it isn't possible to reasonably simply express something in terms of the type system, then I would argue maybe an expect is okay as like a last resort, because at least by using expect, you're forced to document the preconditions that will have been violated if you have used an unwrap. Secondly, I would advise matching exhaustively. If you are matching over an enum exhaustively and someone else has added a variant to this, they will then get an error message pointing to your section of code saying, there's a thing here that hasn't been decided. Go do your homework, dot your I's, cross your T's. And it forces the person who is making that change to propagate what they have done throughout the code base. So you no longer end up in a state where your program compiles, but it isn't actually 100% correct, which I think is really good. I would also advise mutating quite small scopes. Mutation really requires you to keep invariants in your head, and the fewer invariants you have to bear in mind, the easier code is to write. I'd also advise really avoiding use of unsafe. You're turning off your compiler's checks. If the compiler is unable to help you, you're the only one who can help yourself. It is just far harder to work with. So you should really ask yourself the question, does that 1 or 2% speed up actually merit losing the safety that the compiler would otherwise give you? And I think in most cases, not really, unless you can prove that through use of profiling, that your hot loop here is you really need to get every last bit of performance out of it. I would always advise going for safe and more maintainable code. And finally, I think we need to use weirdness, but quite sparingly. I think a certain amount of weirdness is inevitable when we are kind of gluing together different systems that have different models about how to represent your problem. So we're always going to end up with some of it, but we can kind of use it strategically. So I want to just sort of explore weirdness for a moment here. So in my definition, I would say that weirdness is somewhat equivalent to surprise, as in you look at a code and think, oh, what's going on there? That's weird. And then you should probably do something about it if possible. So when weirdness occurs, it really diverts attention away from what the reader was already thinking about and focuses them on a particular part of the code. Now, if the entire code base is weird, they'll be met with so much noise that it's just going to be unpleasant for them to work with. But if you restrict weirdness to very small particular places, it underlines where extra care and attention needs to be paid. So I think it can be quite useful. But of course, we shouldn't strive to be weird. So fundamentally, I think the best way of avoiding weirdness is by having a debate. Because oftentimes this weirdness comes from little idiosyncratic things that one coder may have done that another coder might not be 100% familiar with. So if we discuss, things will just naturally get better. So this kind of brings me on to argument-free Rust. So I really want to focus our arguments in the place that matter. But it's worth noting that I would differentiate between arguments and debates. Fundamentally, I think a debate is a positive action, as in multiple parties will come together to try to settle their differences. But in an argument, one or both sides will come away from that feeling very bad about themselves, and perhaps they don't feel like they were listened to, or it feels like it was much more difficult than they wanted to get what they wanted done. And I don't think that's very productive. And that's also quite draining as well. Like, if you have a team which is constantly having arguments, you're going to end up with more churn. You're going to end up with people leaving the project and kind of an increase in apathy, and we do not want that. So we really need to foster debate. So at this point, I'd like to sort of describe a little bit more about how our company works and how we have tried to foster debate within Canonical. So Canonical is a company of about 1,000 people. We hire all over the world. We're hiring at the moment. We don't discriminate by time zone, and this fortunately and unfortunately means that we end up with people in very far away places with whom it's very difficult to have a conversation. If I am working quite closely, I am based in the UK, with someone in Australia, one of us is going to be having to wake up, having to go into a meeting at 12 at midnight, possibly repeatedly, and that's not very nice. I wouldn't wish that on anyone, quite frankly. So we need to find a way of having these debates in a way which is both productive and kind of global. So we came up with a couple of approaches for this. Firstly, we tried to use a cross-team code review, as in we just set up a channel in our company messenger, Mattermost, where people would just post their Rust pull requests, and then people from other teams would come along and comment on the patterns that they'd used. And in this way, we kind of built up a shared sense of community and some of the idioms that we're all kind of used to using. Unfortunately, there wasn't really a consensus here, and we kind of need that consensus across all of our code bases if we are to succeed in Rust, because we have 1,000 people, but we also have like hundreds of different projects, it seems. So yeah, it's a real challenge. So The next way that we tried, roughly at the same time as the cross-team code review, was by having open office hours. Literally just get a bunch of people together, chat about Rust. It's a bit of a social event, and there it's a lot easier to build up and agree on one shared sense of what our vision of canonical Rust should look like. This also ran into the same problems, as it's quite difficult to talk to someone on the other side of the planet. So this kind of merited a different approach, which I think, so what we came up with was standardization documents. This has been probably the most effective one, where we literally just document all of the style guidelines that we have in one place for everyone to then see. So what does one of these look like? So this is a snippet of one of our standardization documents. The content here isn't too important, but roughly speaking, we have a description of the thing that we would like to standardize on, a short argument saying, well, argument's a bad word here, but a short argument saying why we would like it to be this way, to hopefully convince people who would otherwise disagree. And then also some visual examples saying, here's what we're aiming for, and here's what we're trying to avoid. A lot of the stuff in these documents is really quite low level and quite simple. Here's a list of some of the things that are in here. It's an excerpt from the table of contents. Again, the content here isn't too important, but if you take a look, you'll see that actually a lot of this stuff it's really quite simple, because we don't want to be having debates about things which fundamentally don't matter too much. You and your coworkers will have like a finite amount of energy that you can spend here. So if we can make sure that the debates we are having are focused on interesting things rather than uninteresting things, then I think that's a good thing. Every time we have one of these low-level debates, we can always just point to this and say, hey, this is the way we're doing it. So how did we put one of these together? And how would you go about putting one together for your organization? So firstly, we made note of the repeated arguments that we were having where different outcomes were occurring so that we can then standardize upon them. If you do any coding in your own time, an exercise I did as well is just as I'm writing, I have in the back of my mind, if I've done something and there could be another way of possibly doing it that is equally good but just different, I'll note that down and maybe discuss it later. Once all of these points have been kind of gathered, you just write them up, essentially. Just write up the generally applicable ones to keep it relatively short. These are going to be some quite lengthy documents, so you've got to be quite selective with these. And then, once the write-up has happened, you have a discussion with the most experienced Rustaceans that you can get your hands on. There will probably be a lot of changes that need to be made. That is a good thing. The extra experience that they will have brought from other places will be able to make far better informed decisions for the conventions you wish to enforce. So once you've gone through with this small group, you would then expand to a larger group of Rustaceans from all levels of ability. Now, the key here is we want something which everyone can kind of roughly agree on without it feeling like a design-by-committee exercise. Because we're trying to create something that has a very strong personality, and if everyone comes in from the beginning and chucks all of their ideas in, it's going to get kind of a little bit messy. So a certain amount of restriction was kind of necessary here. And finally, you do a 1.0 release. Of course, there's always more stuff that's going to be added to these things in future, but the release is kind of the moment where we say, okay, guys, this is what we're going to be doing. This is how we're going to be doing it. So that's kind of the process on hard mode. I appreciate that not all organizations are going to have the time and money available to dedicate a couple of people just to work on something as low level as standardization like this. So I kind of want to give you an easy mode, which is that, well, actually, all of the guidelines which we were putting together are fully open source. You can use them if you like. Please do. If you agree with them, thank you. If you find yourself agreeing with them, great, fantastic. Please take them and use them. If you disagree, we have an RFC process, and I'd be very, very happy to have debates on all the minor nitty-gritty points about this. And even if you disagree with large parts of this, just, feel free to fork it. Use it for your own organization. It's licensed under GPL3 to keep it nice and open. Go for it, is what I'd say. So what's next in this effort? So we have our standardization documents. We have possibly our developers reading these documents and applying what they have learned. What comes next is, well, more standards, sorry, because as it goes on, we're just going to find more places that we have trivial differences, and, well, we can make standards with these. But reading all of these large documents is going to get a little bit taxing after a while. So I've actually been running a little bit of an experiment into automating a lot of these things. It's not possible to automate every single one of them because a lot of them have their roots in like natural language, and I don't want to go there, quite frankly. But there are quite a few of these guidelines that can be mechanically enforced. So on my GitHub, if you come find me, you will be able to see some of the work that I've been doing on that, and I hope to present it at some point in future as well. But on a more human front, we are also going to have open office hours. So the office hours that we have inside of the company, we're going to be opening them up to other people to join. So if you want to have a discussion about these minor differences you might be encountering, yeah, feel free to come along. I'm going to pop some details of that in the Discord, and if this is on YouTube, in the comments or description, I guess. And that's about it. Thank you for listening, and have fun.